Alright, pre-calc. So today we're going to look at our last section for the first chapter, the prerequisite chapter. We're going to split this into two parts though. So today we're just going to look at the linear inequalities. Part 2 will be about absolute value inequalities. So three things we want to look at here. We'll talk about interval notation, remind ourselves what that is, how we solve a linear inequality, and then extending that to what is called a compound linear inequality. Okay, so interval notation is the way in which we can show solutions to a set. So if we say A to B like this with parentheses, and the difference between parentheses and brackets is a big deal here, this would mean that A is less than X is less than B, and you'll notice that neither A nor B is included. So parentheses tell us that A and B, or whichever value it's next to, is not included. In this example, it would tell us that we actually have less than or equal to, and so we include both A and B. Now it doesn't have to be all parentheses or all brackets. We could have a mixture like something like this. Whoops, let's say negative 3 to 2 is what I mean. So this would tell us that our solutions for this inequality are between negative 3 and 2 and including negative 3, because we have a bracket with negative 3 and a parentheses with 2. Right, so here, the way we would write this one, this goes from A to infinity. So this tells us that X, our solution, is greater than A. Okay, and we'd never have a bracket around infinity because we're never actually going to get there, so we just always have a parentheses. We could easily change that to, let's say, a bracket of A to infinity, and so it would be very similar, except for now, whoops, that should be X. Except for now, X is greater than or equal to A. Okay, we could change this around a little bit too and start at negative infinity to, let's say, 4 and a parentheses. Now this would tell us that X is less than 4 because we're going from negative infinity up to 4 but not beyond 4. Okay, so that is a way, interval notation is just one way to show a solution. You'll see that a lot in the future, so it's important that we obviously speak the same language in the class. Linear inequalities then are going to be just any inequality. We're going to solve it just like a linear equation with one exception. That one exception we need to be careful about. When we multiply or divide by a negative number, we switch the symbol. Now this is important. It's only the number that we multiply or divide by. We could have a negative on the other side and it's not a big deal as long as the number that we multiply or divide by is not negative. If it is, we switch the symbol. So first one here, I'm going to solve it just like an equation. Treat the inequality symbol like your separation left and right. I'm going to start by subtracting 2, so I'd end up with negative 3x is less than or equal to positive 3, and then I'm going to divide both sides by negative 3. So here is where that piece comes in, and since I divided, again negative 3's cancel out, I need to switch my symbol, and so I get x is greater than or equal to negative 1. If we're going to do interval notation on this, we'd say a negative 1 all the way up to infinity. So negative 1 to infinity. Okay, here, still solving it just like an equation. We need to get our x's on our same sides. We don't like that. It doesn't matter which one we get them on. I'm going to start by saying let's add 2x. Okay, it's not the only way to do it. That's just how I'm going to do it in this time. So negative 4 greater than 3x plus 5. And then I'm going to subtract 5 from both sides. So I'll end up with negative 9 is greater than 3x, and now I divide by 3. Okay, we need to be careful here. We do not switch our symbol. We're going to get negative 3 is greater than x. We're not going to switch our symbol because the number we divided by was positive. Doesn't matter if this number is negative. It only matters if the number we divide by is positive or negative. And now also I'll say one other thing here. A lot of us don't like when we have x on our right side. It's kind of hard for us to read, and that's perfectly fine. You can switch so that you get x and negative 3 on the other sides. In this case, then we need to actually switch our symbol. So we have x is less than negative 3, which means we go from negative infinity, writing this in interval notation, up until negative 3, and we have a parenthesis this time because it does not include negative 3. A compound linear inequalities then are just an extension of inequalities. And now we're going to have two conditions. So a lot of times we call these and or inequalities. And we're going to perform operations on all sides. So sometimes, like this first one, since we have two symbols, that means two conditions, we're going to really think of this as having two lines to draw, and therefore 1, 2, 3 sides. We do the same thing. We need to subtract 1, and just like we did it on both sides before, now we need to do it on all 3 sides. So we're going to end up with negative 4 is less than 2x is less than or equal to positive 2. And then dividing both sides by 2, so we get x in the middle is greater than negative 2 and also less than or equal to 1. And in this case, the interval, we'd start at negative 2, parentheses, because we don't include it, and we go to 1, bracket, because we do include it. Okay, we could also graph this by shading, which we have probably seen in the past. We can put our 0, we can put our 1, and our negative 2. Okay, now we include an open circle at negative 2 because we don't include that, and a closed circle at 1 because we do include that, and we could shade everything in between those two values. Okay, same idea over here. We need to subtract 3 from all sides, so we're going to get negative 2 is less than or equal to 2x is less than 8, and then we're going to divide by 2, so we get negative 1 is less than or equal to x is less than 4. So this is another AND inequality. We could now do our interval notation. Negative 1 to 4, that gets a parenthesis on 4 because it's not included. And we could do the same kind of graphing if we wanted. For the sake of time, we're going to skip over that one. So that was the last piece, compound linear inequalities. I showed you two AND inequalities, and AND inequalities are almost always going to shade in the middle and between the values. We could also have had OR inequalities, which are almost always going to shade outside of the two values, meaning that we would graph them away. Okay, we've got interval notation where brackets include the value, like an equals to under the less than or equal or greater than sign, and parentheses do not. So it would be strictly less than or strictly greater than. Okay, we'll see you in class.